We don't really use pulmonary artery catheters all that much anymore in the UK, but you might get asked to talk through the graph relevant to a pulmonary artery catheter in your exam, so you need to know the information. So it's a very distinctive graph and it looks like this, and you need to be able to talk through each of the stages and why the graph looks like it does. So you start off by putting the catheter into the jugular vein and tunneling it through into the right atrium. So you start off with this low pressure waveform because the right atrium is a very low pressure but high flow system. From the superior and inferior vena cava, the blood flows into the right atrium. Now it is a contractile pulsatile chamber, so you do get a fluctuating waveform between about 2 millimeters of mercury and 6 millimeters of mercury, but it will vary depending on hypovolemia, venous overload, all those kind of things. But normal values, about 2 to 6 millimeters of mercury. Then as the tip of the catheter, which is where the pressure is being sensed, as that moves through the tricuspid valve into the right ventricle, you get a sudden change in the morphology of the waveform and you get this huge ventricular contraction. And it gives you these peaks of pressure of about 22 millimeters of mercury. But note, because you're now in the ventricle will go through a process of diastole or relaxation, where the pressure will then drop to zero as it's sort of sucking in blood from the right atrium. So you get a very characteristic higher pressure, but also it goes down to zero. So if the pressure is hitting zero, the tip of your catheter is usually in a ventricle. Then what happens is you move through from the right ventricle into the pulmonary artery and you've gone through the pulmonary valve. Now the pressure is going to stay the same at the peak. If you think about it, the ventricle is generating the pressure required to open the pulmonary valve and push the blood up into the pulmonary artery. So that peak pressure is going to stay the same because you're just opening those gates, and that's when the pressure starts to equalize. So the pulmonary artery has the same peak pressure at about 22 to 24 millimeters of mercury, but because the pulmonary valve is then closing and there's elasticity within the pulmonary artery, that pressure does not drop back down to zero. It is maintained and it only drops down to about 10 millimeters of mercury. So you know when you've moved from ventricle to pulmonary artery because the diastolic pressure is no longer zero, it's up at about 10. And that comes up in the exam a lot. They'll say, where is the tip of your catheter if this is the pressure values that you're getting? Key is in the diastolic pressure. If it's zero, you're in the ventricle, and if it's higher than that at around 10, then you must be in the artery because the valve is what maintains that diastolic pressure. And finally, we get the wedge pressure. Now this literally means once you've tunneled your catheter as far as it will go, it's going to go through the pulmonary artery into a tiny arteriole. The vessels are going to get smaller and smaller until the catheter is too big to go any further, and it will literally get wedged in a small vessel, usually an arteriole. Now the logic here is there are no valves between where your catheter tip has got stuck and the left atrium. So as you've got a continuous column of blood between your catheter tip and the left atrium. So therefore the pressures you are measuring are pretty reflective of left atrial pressure. So if you get asked, and what does pulmonary capillary wedge pressure tell you? You can say it is representative of left atrial pressure. And that's why we use this as a measurement technique. It's an accurate way of getting left atrial pressure, which gives you an idea of preload for the left side of the heart. And as you'll see here, the pressure waveform suddenly changes and you're dropping way back down to a similar pattern. It looks very similar to the right atrial pressure, but because it's now the left-hand side of the heart that we're measuring, it is clearly elevated because the left-hand side of the heart does higher pressures in the systemic circuit. So the pressures you're looking at are about 12 millimeters of mercury systolic and about 8 for diastolic. So it's a pretty simple once you get your head around it, but you just practice talking it through when you're preparing for the exam, and it should start to make sense.